Welcome, ladies and gentlemen. So what I'd like to do is show you how to evaluate for our 6 trigonometric functions when given a function here, or an equation here, as well as a constraint. Now, the first thing is kind of really important to really understand, well, how do these constraints kind of work? You know, when it tells you the quadrants, that's kind of simple enough. Hey, quadrant 1, 2, 3, or 4, right? Well, what does it mean when sine of theta is 0 or cosine of theta is, less than 0? Well, what I like to think about that is just kind of go back through, your Cartesian coordinate system and think about, what is positive and negative, just in your coordinates. And if you look at the first quadrant, we know that, the points, the cosine of theta, or the, x value is positive, the y value is positive. In the second quadrant, the x value is negative, the y value is positive. In the third quadrant, they're both negative. And in the fourth quadrant, the x value is positive and the y value is negative. So when we're talking about when sine is greater than 0, that means we're only talking about it's either in the second quadrant or in the first quadrant. So when we're talking about when cosine is less than 0, that means we're talking about when it's negative. Well, cosine is negative in the second or in the third quadrant. OK, so I wanted to kind of go over that first. So therefore, you have an idea, because I probably won't have time. I don't want to recreate the diagram for each of the problems. All right, so basically, to evaluate our 6 trigonometric functions, though, we need to create a triangle. And we just can't create any right triangle because now we have a constraint. That constraint has to be where sine of theta is greater than 0, which we already discussed is either in the first or the second quadrant. All right, now, remember sine represents opposite over adjacent. And what's difficult about sine is that negative sign is kind of a little bit. That's right in front. So I don't know what is negative. Is it the opposite or is it the adjacent side? Now remember, if its sine is greater than 0, we have 2 triangles that it could be. Right? And those 2 triangles need to look like that. Always theta is with respect of the origin. And the right angle is always with respect of the x-axis. Now, opposite over adjacent, one of those has to be negative. Or in the thing. Well, if the opposite side has to be positive, right? Because you can see here, here's your hypotenuse. Here's your hypotenuse. Here's your adjacent side. Here's your adjacent side. And then here's the opposite side. And here's the opposite side. So if you look at this, remember, let's write this in front. The main important thing to know is, negative 2/3 is the same thing as negative 2 over 3, which is the same thing as 2 over negative 3. So that negative could be in the numerator or it could be in the denominator. So if it's in the numerator, that means negative 2. That means the opposite side is negative. Well, is it possible if sine is positive for it to be negative? No, right? So therefore, that means the negative has to be in the denominator. That means the adjacent side has to be negative. Well, if the adjacent, which one of these has an adjacent side that's negative? This triangle. So therefore, now I can just focus all of my attention on using a triangle in the second quadrant. So I know that now the adjacent side is negative 3. The opposite side is going to be positive 2. Now I just need to figure out what the hypotenuse is. Now this is not a perfect square. It's not a Pythagorean triple. So therefore, I'm going to have to use the Pythagorean theorem. So I do 2 squared plus negative 3 squared equals hypotenuse squared. Let's just call that c, equals c squared. OK, remember, side squared plus side squared equals hypotenuse squared. So 2 squared is 4 plus negative 3 squared is 9 equals c squared. 13 equals c squared, square root, c equals the square root of 13. OK, so now we just need to evaluate for the sine, cosine, and tangent. So remember, sine, cosine, and tangent. Sine of theta is going to be opposite over hypotenuse. So that's going to be 2 over the square root of 13. Remember, whenever we have a square root in our denominator, we have to rationalize the denominator. So I'm going to multiply by the square root of 13 on the top and the bottom. And therefore, I get 2 square root of 13 over 13. For the cosine of theta, that's going to be adjacent over hypotenuse. So that's going to be negative 3 over the square root of 13. Again, I'm going to have to rationalize the denominator again. However, to save some time, I'm not going to show this. I'm just actually going to show you what the answer would be, which would be negative 3 square root of 13 divided by 13. Tangent, fortunately for us, we already know the answer for tangent because that's the original one, right? So that becomes negative 2/3. Or you can just write it in front, because we know actually the 3 is the negative. So now let's go ahead and determine our reciprocal function. So the cosecant of theta is going to be the reciprocal of sine. So that's going to be the square root of 13 over 2. The secant of theta is going to be the reciprocal of cosine, which is going to be negative square root of 13 over 3. And the cotangent is going to be the reciprocal of tangent. That's going to be a negative 3/2. OK, perfect. So now let's go ahead and go to the next one, which would be the tangent of 4/3. Again, remember this is opposite over adjacent. All right. But in this case, we have cosine is negative. I don't like that one. All right, so let's go and take a look at, well, where could my opposite be 4/3, right? When you think about this, you say, all right, well, the only thing that makes sense to me is here's my angle theta, right? Opposite would be 4, and adjacent side would be 3. That makes sense. But it says that cosine has to be negative. Well, how can cosine negative and it be positive, right? Because if cosine was negative, then it would have to look like this. But then that would be negative, but then that's positive, so therefore it would make a negative ratio. So how can I make this ratio become positive? Well, if I redraw it, where now my adjacent side is negative 3, and my opposite side is now negative 4, now I have a triangle where cosine is negative, and negative 4 divided by negative 3 is positive 4/3. This one gets everybody all the time. OK, so now that's going to be our triangle that we're going to focus on. So negative 3 is going to be our adjacent side. Negative 4 is going to be our opposite side. And then we need to figure out our hypotenuse. And hopefully by now you guys understand that this is a Pythagorean triple. So therefore, that's going to give us 5. If you do not believe me it's a Pythagorean triple, then go ahead and use the Pythagorean theorem. Negative 3 squared plus negative 4 squared is going to equal your hypotenuse squared, which ends up being, solving, you're going to get 5. All right, so now let's go ahead and identify our sine, cosine, and tangent. So sine of theta is going to be opposite over hypotenuse, negative 4 over 5. Cosine of theta equals adjacent over hypotenuse. And tangent of theta is opposite over adjacent, which they already have for us, which is 4/3. So you can see how this works. Negative 4 divided by negative 3 gives you positive 4/3. Reciprocal identities, we always like these because especially when we don't have to rationalize the denominator, we can just rewrite them. That's going to be a negative 5/4. Secant of theta equals a negative 5/3. And the cotangent of theta equals 3/4. So there you go, ladies and gentlemen. That is how you evaluate your 6 trigonometric functions. That is how you evaluate your 6 trigonometric functions given an equation as well as a constraint. Thanks.